Today you're going to be taking notes on word problem proportions. Here is your notes page. Please make sure that you write down everything that I do onto your notes page. Okay, we've learned how to solve proportions with basic numbers, but now we are going to write our proportions from a word problem and then solve them, which is the easy part. So the first question you have there, a pet store has 6 dogs for every 9 cats. How many dogs are there if there are 270 cats? Now with the word problem proportions, you need to be careful because of the wording. Some of them are a lot easier than the others. Okay, I'd like you to mark up your text, underline the important information. We have 6 dogs for every 9 cats. We want to know how many dogs are there for 270 cats. So in this word problem, I like to just set up, we're gonna write a proportion. So blank over blank equals blank over blank. I like to write my word proportion in words first. We want to have dogs over cats equals dogs. Over cats. Okay, so for every, and that's our word problem proportion in words. Now we're going to put it into numbers. So for every 6 dogs, there are 9 cats. We want to know how many dogs, when we don't know a number, we use a variable, for 270 cats. There's your proportion. Now we're just going to go ahead and solve that. And at this point, that should be pretty simple for you. We will use the cross product property. So 9, we could use any property. I'm going to use the cross product property. 9 times x. And then we are going to do 6 times 270. Guess multiplication would have worked well also. 9x equals, when you multiply that, you can use obviously a calculator if you wanted to, 1,620 divided by 9. One-step equation, just solve that, and you get x equals 180. And of course that's a word problem, so we should label that 180 dogs. And there's your answer. The hardest part is setting it up properly. This one is easier. They do get harder. Let's move on to the next one. Okay, here we have the ratio of boys to girls in Mrs. Sicoli's favorite class is 3 to 4. So 3 represents the boys and 4 represents the girls. You could label that up as you read. Oops, sloppy. If there are 12 boys, how many are girls? Okay, so in words we have boys over girls equals boys over girls. Okay, let's put that into numbers. We have 3 boys for every 4 girls. We want to know if there are 12 boys, how many are girls? There's your proportion. Okay, these numbers are nice and small, so I'm going to use the multiplication method. 3 times 4 is 12, so 4 times 4 is 16. So x equals 16, and I'm going to label that girls. Okay, it's also a good idea on word problems to always make sure your proportion makes sense. If, let's say, we did something on here and we got like a number like 2. Okay, obviously that wouldn't make any sense. How could we have 2 girls when the number of boys to girls was 3 to 4 in the first place? So always take a look at your answer and make sure it makes sense. Does it make sense? For every 3 boys, there's 4 girls. For every 12 boys, there's 16 girls. And that makes somewhat of sense. Okay, moving on to the next one. Okay, the ratio of vanilla to chocolate lovers is 6 to 11. So 6 represents the vanilla, right? And the 11 would be the chocolate lovers. if there are a total of 33 people. Now, this word total is very important. If there is a total of 33 people being surveyed, approximately how many are chocolate lovers? Okay, now this problem gives you vanilla lovers and chocolate lovers, but then also gives you the total amount of people that were surveyed, the vanilla and chocolate together. So you have to do a little something before you actually figure this out. What we're actually looking for, I'm going to say, is the chocolate lovers. I'm going to put a little heart there for lovers, over total people. That's the total people that were surveyed. That's our ratio that we're using. Equals chocolate lovers over total people. That's the ratio we're looking for, not vanilla over chocolate or chocolate over vanilla. Okay, so we're going to work here with these two numbers, the 6 to 11. So 6 vanilla lovers and then 11 chocolate lovers. All together, that gives me a total of 17 total people. So I'm going to use those numbers, the chocolate and the total, in my proportion. So I have 11 chocolate lovers to a total of 17 people equals, we want to know how many chocolate lovers if there was a total of 33 people. Okay, now this says approximately because we're not going to get a whole number here. So now, from there, once you have your proportion set up, pretty simple how to solve that. You're going to do your cross products property, 17 times x, and 11 times 33. Again, you'll be using your calculator on that. You get 363. Solve that one-step equation. Divide by 17 on both sides. And x equals 363 divided by 17. You get a crazy decimal, 21.35, a non-terminating decimal, and it goes on and on forever. We're going to round that to the nearest whole correctly. So it would be approximately 21 chocolate lovers. And there's your answer. Okay, this one is similar to the last one. Emily is planting flowers in her garden. She wants the ratio of roses to tulips to be 5 to 2. So 5 represents my roses, 2 represents my tulips. Emily wants to plant a total, there's that word again, total, of 40 flowers. How many tulips should she plant? So we're looking for tulips for total. So our ratio in words is going to be tulips over total flowers equals tulips over total flowers. Okay, so if there's 5 roses and 2 tulips, in that ratio, we have a total of 7 flowers. So we need to figure out, we have tulips and total flowers, 2 tulips for every 7 flowers. We want to know how many tulips for a total of 40 flowers. There's your correct proportion you're going to use to solve. Cross products property, 7 times x is 7x. 40 times 2 is 80. Divide by 7 on both sides. And you get 80 divided by 7, which is 11 point, again, and non-terminating decimal we get, 42, blah, blah, blah. We're going to round to the nearest whole number because you're not going to plant 0.42 of a flower. So we're going to round that to approximately 11 tulips. And there's your answer. Okay, moving on to the next one. Make sure you're writing down questions if you have any. The ratio of pizza lovers to non-pizza lovers is 8 to 9. So 8 represents the pizza lovers, 9 represents the non-pizza lovers. If there is a total, again, they're dealing with the total again, of 76 people, approximately how many are pizza lovers? So we are talking about, pause the video if you want and write your own proportion in words, pizza lovers to total people equals pizza lovers to total pizza. So, total people, sorry. So we have 8 pizza lovers and 9 non-pizza lovers. If you add those together, you get a total of 17 total people. Okay, so we need to put in pizza lovers and total people. That's what we're talking about here. So our proportion in numbers, go ahead and pause it, write your own, then check it. 8 pizza lovers over 17 total people. We want to know how many are pizza lovers out of 76 total pizza lovers. Total people. Sorry. Find the cross product property. Multiply 17 times x. You get 17x. 8 times 76 is 608. You divide one-step equation to solve that by 17. And you get x equals, again, a non-terminating decimal, 35.76, blah, blah, blah. We're going to round that to the nearest whole correctly. Approximately 36 pizza lovers. And again, these word problems, we should label them. As you notice, I've been labeling all of them. And then, moving on to number 6. Okay, we have a map has a scale of 0.75 inches equals 12 miles. The distance from Fort Myers to Cape Coral is 6.25 inches. How many actual miles separate Fort Myers from Cape Coral? Okay, so this is, when you have a scale, a picture of something, and you're talking about the actual scale. It's a scale model. You can do this with when you're making a building, a scale of a building, you'll make it smaller, and it's always proportional to the actual. Same thing with maps. Maps should be proportional when we create a map. If you look at a map, usually you look at them online. Okay, they are drawn to scale. So in this one, we have 0.75 inches to 12 miles. If it's 6.25 inches away, what's the actual mileage? Okay, a couple different ways you could write this. You could say scale size over actual size. I'll use both of these interchangeably. Equals scale over actual. Or you could say the inches over miles. And the inches is always your scale measure, and the miles is always your actual. Doesn't matter. As long as you put everything in the right spot is what really matters, okay? So the scale of the picture or of the map is for every 0.75 inches, and if you want to label them, you can, but you don't have to, equal over is 12 miles. We want to know if it's 6.25 inches, what is the actual mileage of those two cities? So that would be your proportion that you would set up. You cross multiply. Cross products property would be easy enough to do. 0.75 times x is 0.75x. 6.25 times 12 equals 75. One-step equation. Divide by 0.75 or 75 hundredths on both sides. And you're left with x equals 100. And of course, you should label that miles. So the actual distance of those two cities is 100 miles. Okay, let's try one more like that. Again, a scale on a map is 2 inches equals 18 miles. The distance from Nowhereville to Somewhereville is 12.8 inches. How many actual miles apart are the two cities? So you could do the scale over actual, and I want you to do these word proportions for every word problem you have, because I think it helps you understand what they're asking for and where everything needs to be set up. Again, if you want to use scale over actual, or if you want to use inches over miles, that's your choice. And I don't want you to abbreviate too much, because sometimes your abbreviations don't make much sense. So for every 2 inches, we have 18 miles. We want to know if something is 12.8 inches on the map, how far is the actual distance? There's your proportion. Cross products property, 2x equals 12.8 times 18. You get 230.4. Oops. Divide by 2 on both sides, and x equals 115.2 miles. And on problems like this, I didn't mention on the last one because we didn't have a decimal, you can leave that as a decimal. We don't have to round that to a whole because we can have 0.2 of a mile. So 115.2 or 200ths miles. And you should leave that as the decimal. Don't round that. The only time we round to a whole number is when we have to. If this was a crazy decimal, a non-terminating decimal, yes, we would definitely round that maybe to the hundredths. But depending on the problem is how you're going to round it. If you're not told how to round it, again, if you round properly, that's the most important. But you have to also see what makes sense. Okay, one last type of problem I'm going to show you. This is called indirect measurement, okay? And you could figure out the height of an actual height of a building based off of, knowing the actual height of something else and then measuring the shadow. So we have a 6-foot tall person casts a 12.5-foot shadow. At the same time, a building casts an 115.7-foot shadow. How tall is the actual building? Okay, so we're going to figure that out using this information. And I would like to put this as the height, the actual height of the person, or the object, I should say, the object height over shadow height. That would be my word problem proportion there. This again would be the object height, which is in this case the building height, over the shadow height. Okay, so the person is 6 feet tall. That's the actual height of the person. And that person's shadow is 12.5. So this ratio here is based all upon the person. And then this ratio here is going to be based on the building. So we have, okay, I didn't underline here. The building casts an 115-foot shadow. So that's the building's shadow height. So that's going to go right down here. We want to find out the actual height of the building. So this ratio is based all on the building. Okay, now there's your proportion. Let's solve that. We have, I didn't label this. This is all about the person, and this is all about the building. Just kind of helps you understand where I got that information. Cross products property, 12.5 times x is 12.5x. 115.75 times 6 gives you 694.5. Solve that. Divide by 12 and 5/10 on both sides. And you get x equals 55.56. 55 and 56 hundredths feet tall. That's the actual height of the building. Okay, obviously you can't measure that building with a ruler, but you can measure the shadow on the ground. It's an awfully long shadow, but it can be done. So there you have it. Those are your word problem proportion notes. We'll be doing a few different ones in class. If you have any questions, please make sure you write them down, and I will see you the next time in class.